champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So in today's session we are going to discuss NEET 2023 chemistry paper and we are 50 questions here. So let's start the session. The first question is from the chapter D and F block elements and the question is the stability of Cu2 plus is more than Cu plus salts in aqueous solution due to. Options are enthalpy of atomization, then hydration energy, then second ionization enthalpy, and the last option is first ionization enthalpy. Okay, so let's see. We know that Cu2 plus ion is smaller in size as compared to Cu plus ion, right? It is smaller in size than Cu plus ion because it contains less number of electrons. Okay. Now, due to this smaller size, charge of ions remain concentrated and they are not spread widely. Okay, so there is accumulation of charge. Accumulation of charge. It means that Cu2 plus has a greater charge density, isn't it? Greater charge density than Cu plus ion. Okay. Now what will happen due to this greater charge density? Due to this accumulation of charge, the polar water molecules form stronger bonds with Cu2 plus ion, releasing more energy. Okay. So stronger bond with water molecules is formed. Okay. Also, more amount of energy or large amount of energy is released. And we know that this energy is known as hydration enthalpy. Okay, so it has a high hydration enthalpy. Okay, so we can say that due to this high hydration enthalpy, this Cu2 plus ion is more stable than Cu plus ion. Okay, right? Because it forms strong bond with water molecules. So option B will be the correct answer. Hydration energy. Okay, the stability of Cu2 plus is more than Cu plus due to hydration energy. Question number 52 is from the chapter Surface Chemistry and the question is which one is an example of heterogeneous catalysis. Okay, so what is heterogeneous catalysis? It is a type of reaction where the phase of reactant and product is same as the phase of the catalyst. Okay, let's write it down here. Phase of reactants and products is same as the phase of catalyst. Okay, so let's see one by one. The first option is hydrolysis of sugar catalyzed by H plus ions. So hydrolysis of sugar. So we know that hydrolysis takes place in the aqueous medium, right? So the reactants and products will be in aqueous medium and H plus ion is the catalyst here. Okay, so H plus, as you can see that this is an ion and ions are found in aqueous solutions. So here the catalysts as well as reactants and products are in aqueous phase. So all are in liquid or aqueous phase. So this is an example of homogeneous catalysis, not heterogeneous catalysis. Okay, so the first one is the example of homogeneous catalysis and all are in aqueous phase. The exact reaction, chemical reaction is like this: C12H22O11. This is aqueous phase. This is the sugar, right? Now this is being hydrolyzed. So water is present, which is again liquid. The H plus ion is from sulfuric acid. Okay, so H2SO4. This is also in liquid form. Then what is formed? Glucose plus fructose is formed. Okay, So this is not the example of heterogeneous catalysis. Let's move to the second option now. Second option is decomposition of ozone in presence of nitrogen monoxide. So we know that ozone is a gas and nitrogen monoxide is also a gas. Okay, so this is also example of homogeneous catalysis. Okay, all are in gaseous phase here. So again homogeneous and all are in gaseous phase. Then the third one is combination between dinitrogen and dihydrogen. So dinitrogen and dihydrogen all both are gas to form ammonia in the presence of finely divided iron. So the reactants, that is dinitrogen, dihydrogen, are gas. The product ammonia is also a gas, but the catalyst, that is finely divided iron, is a solid. Okay, iron is a solid. So here we can see that the phase is not same. So this is an example of heterogeneous catalysis. Okay, so option C will be the correct answer. Okay, here the reactants and product are in gaseous phase, right? Whereas the catalyst is in the solid form. Okay, let's write down the reaction here. This is nitrogen, dinitrogen plus dihydrogen. So in the reaction it will be 3 molecules of dihydrogen gas. The catalyst will be solid iron in the finely divided form and the product will be ammonia. Okay. Now the last option, what does it say? The last option is oxidation of sulfur dioxide into sulfur trioxide in the presence of oxides of nitrogen. So all are oxides here. That means all are gases. Okay. So in the last one, all are gases. So this is also example of homogeneous catalysis. Okay. Homogeneous, not heterogeneous. So the only example of heterogeneous catalysis is option number C, combination of dinitrogen and dihydrogen to form ammonia in the presence of finely divided iron. Question number 53 is from the chapter States of Matter, and the question is, which amongst the following options are correct graphical representation of Boyle's law? Okay, so we know that according to the Boyle's law, the product of pressure and volume is constant. Okay, it is equal to nRT. So we can say that P is inversely proportional to V. Okay, pressure is inversely proportional to the volume. Now if we draw the graph of pressure versus volume, pressure and volume this side, then it will look something like this, because these are inversely proportional. Okay, at the same time, if we draw a graph of pressure versus 1 by V, okay, 1 by V, then it will be a straight line, because from here you can see that P is directly proportional to 1 by V. Okay, and if the graphs at different temperatures are shown, then the graph with maximum slope will show the highest temperature. Okay, so in the first one, let's say this is graph number 1, this is graph number 2. So in the first one, this uppermost graph will show the highest temperature. Okay, the graph at highest temperature. And in graph number 2, this one with the maximum slope will show the maximum or highest temperature. Okay, so let's see. In the first option, we have pressure versus 1 by volume graph. Okay, 1 by V. So it will be a straight line like this. This is correctly represented. And the temperature T3 will be the maximum and T1 will be minimum, right? So T3 maximum, then T2 and then T1. Yes, this is the correct representation. So this is correct. Now let's move to the second one. This is pressure versus 1 by volume again. So this should be a straight line, not this type of graph. Okay, this will be in case of P versus V graph, not 1 by V. Okay, so this is incorrect. Now the third one, we have pressure versus temperature graph. So in case of Boyle's law, we find the relation between pressure and volume, not pressure and temperature. Okay, so this will also be incorrect. And the last one is pressure versus volume. Yes, it looks like this, but for the highest one, this graph, T1 should be the maximum. Okay, T1 should be the maximum temperature. So the sequence should be T1, then T2 and then T3. Okay, so this sequence is incorrect. That means the only correct option we have is option number A. Okay. Question number 54 is from the chapter Chemical Kinetics, and the question is given below are two statements. One is labeled as assertion and the other is labeled as reason. Assertion says a reaction can have zero activation energy, and according to reason, the minimum extra amount of energy absorbed by the reactant molecules so that their energy becomes equal to threshold value is called activation energy. So in the light of above statements, choose the correct answer from the options given below. Okay. So if we talk about the assertion, a reaction can have zero activation energy. Yes, this is true. A reaction can have a zero activation energy. For example, radical reactions. Okay, the reactions which involve radicals, okay, can have zero activation energy. The reason says the minimum extra amount of energy absorbed by the reactant molecules so that the energy becomes equal to the threshold value. So this is the correct definition of activation energy. Okay, this is the correct explanation of what is activation energy, but this does not explain why a reaction can have zero activation energy. Okay, so this is not a correct explanation of the assertion, although this is a correct statement. So both assertion and reason are correct, but reason is not the correct explanation of A. So option A will be the correct answer. Both A and R are true, but R is not the correct explanation of A. Okay, and here you should remember that the type of reactions which have zero activation energy will be independent of temperature. Okay, this type of reaction will be independent of temperature. Independent of temperature. Their rate constant will not vary with temperature. Okay. Now question number 55 is from the chapter Organic Chemistry, and the question is in Lassane's extract of an organic compound, both nitrogen and sulfur are present, which gives blood red color with Fe3 plus due to the formation of. Okay, so what is Lassane's test? It is a test that is used for the detection of elements such as nitrogen, sulfur and halogens. Okay, so these elements can be detected with the help of Lassane's test. And how is this test performed? First we take a sample. Okay, suppose this is a test tube and it contains the sample. Now this sample might contain nitrogen, sulfur or halogen in it. Then we will fuse this with the sodium metal. Okay, sodium metal. And as we know that sodium metal is highly reactive. It is highly reactive. So this reactive nature of sodium metal will break the bonds within this sample molecule and some elements will be released. Okay, so this sodium will react with these samples, right? So this is known as sodium fusion extract. Sodium fusion extract, because we have fused the sample with the sodium metal. Okay, now what happens if the sample contains halogen? Okay, suppose there are some halogen in the sample, then sodium will react with this halogen and it will make sodium halide. Okay, it will form sodium halide. Similarly, if the sample contains nitrogen, then sodium will react with this nitrogen, and in addition to this it will also react with carbon and it forms sodium cyanide. Okay, so with nitrogen it will form sodium cyanide. If the compound contains sulfur, then what will be formed? Sodium will react with sulfur and it will form sodium sulfide. Okay, Na2S. So this is the case when only one element is found out of sodium, sulfur, nitrogen and halogen. But if sulfur and nitrogen both are found, sulfur and nitrogen both are present in the sample, then this sodium will react with sulfur plus this one, nitrogen plus carbon. Okay, and it will form sodium thiocyanate. Okay, SCN. So here in the question it is mentioned that both nitrogen and sulfur are present. That means sodium thiocyanate will be formed. Okay, and this compound will will give blood red color with ferric ion. Okay, let's see the reaction. This is thiocyanate. So the thiocyanate SCN minus thiocyanate ion will react with the ferric ion Fe3 plus and it will form the compound FeSCN 2 plus. Okay, and it will give blood red color. So the question has been asked about which compound? Thiocyanate, sodium thiocyanate. So option A will be the correct answer. Question number 56 is also from organic chemistry, and the question is, consider the following reaction and identify the product P. Okay, so this is the incorrect reaction. The correct reaction is CH3, then CH, CH3, CH, OH here, and at last we have a methyl group. Okay, and it is reacting with HBr. So the medium is acidic, and we have to identify the product P that will be formed after this reaction. Okay, so first of all, this OH will react with the hydrogen ion. So what will be formed? Let's see. CH3, CH, CH3. So these are written as they are. And at this position, initially we had OH, which has now reacted with hydrogen. So an additional hydrogen will be present with OH. So that is OH2. And there will be a positive charge on the oxygen. Okay. And at last we had a methyl group. Now this OH2 is same as H2O, right? That means water molecule. So it will remove from here in the form of water molecules. Okay. So there will be removal of water molecule, and what will be formed? CH3, CH. We can write CH3 on the top. Then CH, CH3. And when this water molecule is removed, there will be a positive charge on the carbon atom. Okay, at this position. So you can see that there is a formation of carbocation, and that too a secondary carbocation. Okay, this is a secondary carbocation. Now we know that secondary carbocation is less stable than the tertiary carbocation. Okay, so it will try to shift the hydrogen ion in such a way that a more stable carbocation will be formed. Okay, so a hydride shift will take place to form a more stable carbocation, that is a tertiary carbocation. Okay, hydride shift. So from this position, this hydrogen will shift to the next position. Okay, so that a tertiary carbocation will be formed. So let's see, CH3, CH, sorry, this hydrogen has been shifted, right? So there is no hydrogen with this carbon. We have a methyl group attached to this, and a positive charge will develop at this carbon now. Okay, and here the hydrogen has come, so CH2 and then CH3. Okay, so now we have got a tertiary carbocation. Okay, this is a 3-degree carbocation, that is tertiary carbocation. Now, initially we had seen that the medium contained hydrogen bromide. Okay, so the bromide ion will react with this carbon now. Okay, bromide ion will come and attack at this carbon. So what will be formed? It will get attached at this carbon. So the final product will be CH3, C. Here we have a CH3, and here we'll have a bromide ion. Okay, and then we have CH2 and CH3. So this is the final product. So let's match here. In the first option, we have methyl group and bromide attached to different carbons, okay, to adjacent carbons, which is not true. In the next one, we have bromide attached to the last carbon, which is also not true. Then in the third option, we have bromide and methyl both attached to this carbon. Yes, this is the correct one, right? You can just match it with the final product. So this will be the correct one. Option number D. Okay. Question number 57 is from the chapter Chemical Kinetics, and the question is, for a certain reaction the rate equals to K A square B when the initial concentration of A is tripled, keeping concentration of B constant, the initial rate would. Options are increase by a factor of 6, increase by a factor of 9, increase by a factor of 3, and decrease by a factor of 9. Okay, so the rate is K, that is rate constant, then A square of the concentration of A and B here. Okay, now new rate will be what? Here the concentration of A has been tripled. Okay, so it will be K, and this side will have 3A. Okay, because the concentration has been tripled, and there will be a square, and the concentration of B is constant, so it will remain same. So we can write it as K into 3A square will be equal to 9A square. Okay, and here we have B. So we can say that this will be 9K A square B. So this is 9 times the initial rate. Okay, other things are same, only it has become 9 times. That means the initial rate would be increased by a factor of 9. Okay, so the correct option will be option number B. Question number 58 is from the P block elements, and here we have to match list 1 with list 2. Okay, so the first one in list 1 is coke. Okay, coke. We know that coke is largely used as a reducing agent in metallurgy. Okay, it is used as a reducing agent in metallurgy. So it will be matched with number 3. Okay, so the correct match for A will be number 3. Now the next one is diamond. Diamond. So each carbon atom in diamond undergoes sp3 hybridization. Okay, each carbon atom undergoes sp3 hybridization, and it is linked to how many other carbon atoms? To 4 other carbon atoms. Okay, 4 other carbon atoms by hybridized orbitals. In tetrahedral fashion. Okay, tetrahedral. So there is a tetrahedral arrangement of atoms. So what will be the correct match for diamond? First one. Okay, carbon atoms are sp3 hybridized. Okay, each carbon atom is attached to, it is linked to 4 other carbon atoms in tetrahedral fashion. So the correct match for B will be number 1. Then the third one is fullerene. So we know that Buckminster fullerene contains 6-membered and 5-membered rings, right? And therefore it is a cage-like molecule. So the correct match for fullerene will be number 4, cage-like molecules. So the match for C is number 4. And the last one is graphite. Now we know that graphite is very soft and slippery. Okay, graphite is very soft and slippery, and due to this reason it is used as a dry lubricant in machines which are running at high temperature. Okay, so the correct match for D will be number 2. Okay, D will be matched with number 2. So which option will be the correct one? Second one. A is matched with 3, B is matched with 1, C with 4 and D with 2. So option number B is the correct answer. Question number 59 is from the S block elements, and the question is which one of the following statements is correct? Okay, so the first statement says all enzymes that utilize ATP in phosphate transfer require calcium as the cofactor. So this is incorrect statement because the enzymes require magnesium. Okay, they require magnesium as the cofactor, not calcium. So this is an incorrect statement. Then let's come to the second statement. It says that the bone in human body is an inert and unchanging substance, which again is an incorrect one because bone is not an inert substance. In fact, it is continuously solubilized. Okay, it is continuously being solubilized and redeposited. Okay, now let's move to the third statement. It says magnesium plays roles in neuromuscular function and interneuronal transmission. So which element is involved here? It is not magnesium, in fact it is calcium. Okay, so calcium has role in neuromuscular function and interneuronal transmission, not magnesium. And the last statement says the daily requirement of magnesium and calcium in the human body is estimated to be 0.2 to 0.3 gram. Yes, this is true. It is 200 to 300 milligrams or 0.2 to 0.3 grams. Okay, so option number D will be the correct answer. Question number 60 is from the chapter Solid State, and the question is, a compound is formed by two elements A and B. The element B forms cubic closed packed structure and atoms of A occupy 1/3 of tetrahedral voids. If the formula of the compound is AXBY, then the value of X plus Y is an option. Okay, so here we have two types of elements in a compound, element A and element B, right? Now it is given that the element B forms cubic closed packed structure, cubic closed packed structure, and we know that the number of atoms in cubic closed packed structure is 4. Okay, so the number of atoms of B will be 4, and what will be the total number of voids? Total number of voids will be twice the number of atoms, that means 2 into 4, that is 8. Okay, so the number of atoms of B is 4 and the number of voids is 8. Okay, now it is given that the atoms of A occupy 1/3 of the tetrahedral voids. Okay, that means what will be the number of atoms of A? It will be 1/3 of the tetrahedral voids. Number of voids is 8 for B. Okay, so 1/3 of 8, that means 8 by 3. Okay, so the number of atoms of A is 8 by 3 and the number of atoms of B is 4. Okay, so we know that the formula of the compound is given as AXBY, where X represents the number of atoms of A, that is 8 by 3, and Y represents the number of atoms of B, that is 4. So let's simplify these because it cannot be in fraction. So we'll multiply both by 3. So the value of X will become 8 and the value of Y will become 12. Now if we simplify it further, we know that 4 into 2 is 8, so it will be 2, and 4 into 3 is 12, so 3. So according to this, in the simplest form, the value of X will be 2 and the value of Y will be 3. Okay, so we have to find the value of X plus Y. So therefore X plus Y will be 2 plus 3, that is 5. Okay, so the correct option will be option number D. X plus Y is equal to 5. Now question number 61 is from the chapter Coordination Compound, and the question is, homoleptic complex from the following complexes is. Okay, so what is a homoleptic complex? It is a type of complex in which metal is bound to only one kind of donor group. Okay, so metal is bound to only one kind of donor group or one kind of ligand only. Okay, not more than one. Now let's check one by one. In the first option we have diamine. So one is amine, chlorido nitrito in platinum 3, in platinum 2. Okay, so we have amine, then chlorido, so there are more than one ligand. Okay, so this cannot be the homoleptic complex. Then the second option is pentaamine carbonato cobalt 3 chloride. Okay, so pentaamine is one ligand, then carbonato, this is another ligand. Okay, so again there are more than one ligand or more than one donor group, so it is also not a homoleptic complex. Then we come to the third option. Here we have triamine, again one, triaqua, so again you can see there are more than one ligands. Okay, triamine, triaqua, chromium 3 chloride, so this is also not an example of homoleptic complex. In the last one we have potassium trioxalato aluminate 3. Okay, so trioxalato, only one ligand is there. Okay, so this is an example of homoleptic complex because there is only one ligand. Okay, and what is the formula for potassium trioxalato aluminate 3? It is K3Al oxalate. Okay, so OX3 trioxalato, that means OX3. Okay, so this metal, that is aluminium, is bound to 3 oxalate group. Okay, so option number D will be the correct answer. Question number 62 is from the chapter Chemical Bonding and Molecular Orbitals, and the question is, the correct order of energies of molecular orbitals of N2 molecule is? Okay, so this is a direct question. We know that for molecules like B2, C2, N2, etc., the increasing order of energies of various molecular orbitals are same. Okay, and that is first sigma 1s, then sigma star 1s. Sigma star means anti-bonding. Okay, star represents the anti-bonding molecular orbital. Then we have sigma 2s, then sigma star 2s, then pi 2px, that is equal to pi 2py, and then comes sigma 2pz. Okay, and after that we have pi star 2px, that is same as pi star 2py, and then we have sigma star 2pz. Okay, so let's check which one has this sequence. uh, in the last option we have sigma 1s, then sigma star 1s, then sigma 2s. Yes, this is the same sequence as we have written here, so option D will be the correct answer. Okay, question number 63 is from the chapter P block elements, and the question is, taking stability as the factor, which one of the following represents correct relationship? Okay, so in the first one it is given that indium 3 is greater than indium. That means the stability of indium 3 plus is greater than indium plus. Okay, similarly in the second option it is given that the stability of aluminium plus is greater than the or more than the aluminium 3 plus. Okay, in the third one tellurium plus is more than that of tellurium 3 plus, and in the last one this is just the opposite. It is given that tellurium 3 plus has more stability than tellurium plus. Okay, so looking at these options we can say that plus 1 and plus oxidation plus 1 and plus 3 oxidation states are compared for different elements of group 13. Okay, because all these elements are group 13 elements. Okay, so what are the group 13 elements? Boron, aluminium, gallium, indium, and thallium. Okay, these elements are mentioned in the options. Now we know that for lighter elements more electrons are involved in bond formations. Okay, in lighter elements such as boron and aluminium, more electrons are involved. Okay, but as we move down the group, less and less electrons become involved in the reaction. Okay, so plus 3 oxidation state means the loss of 3 electrons. Okay, loss of 3 electrons, and plus 1 oxidation state means loss of only 1 electron. So as we have seen that for lighter elements more electrons are involved, that means more electron can be lost. Okay, so plus 3 oxidation states are possible for these lighter elements. Okay, loss of 3 electrons are possible. Okay, so plus 3 oxidation states will be more stable for lighter elements, but for heavier elements such as indium and thallium, less and less electrons will be available for bond formation. That means plus 3 oxidation state will be very difficult. Okay, but plus 1 oxidation state will be possible. In fact, it will be more stable than the plus 3 oxidation state. Okay, so let's see. In the first option we have a heavier element. Indium is a heavier one. Okay, so in this plus 1 oxidation state will be more stable, but here it is given that plus 3 is more stable, so this is not correct. Then in the second option, aluminium. Aluminium is a lighter one, right? This is a lighter element. So for lighter elements, plus 3 oxidation state should be more stable, but here it is given that plus 1 is more stable than plus 3. So this is also incorrect. In the third one, tellurium. So tellurium is a heavier element. In fact, it is the heaviest, okay, heaviest among all the group 13 elements. So for this, plus 1 oxidation state should be more stable. Okay, so yes, this is correctly represented here. The last one is just the opposite. This cannot be the correct one. So the only correct is third option. Okay, for tellurium, since it is the heaviest group 13 element, so for this plus 1 oxidation state will be more stable. So tellurium iodide will be more, TLI will be more stable than TLI3. Okay. Question number 64 is from the P block elements, and the question is given below are two statements. One is labeled as assertion A and the other is labeled as reason R. So assertion says that helium is used to dilute oxygen in diving apparatus. So yes, this is a correct statement. Why helium is used to dilute oxygen in diving apparatus? Because it has a very low solubility in blood. Okay, low solubility in blood. That means it does not dissolve in blood. Okay. The reason that is mentioned here says that helium has high solubility in oxygen. So although this is also a correct statement, because we know that gases easily diffuse with each other, right? Gases diffuse easily with each other, and helium and oxygen both are gases, so helium is soluble in oxygen. But this is not a correct reason for the assertion. Okay, this is not the reason why helium is used to dilute oxygen in diving apparatus. Okay, so both the statements are correct, but reason is not the correct explanation of assertion. Okay, so option A will be the correct answer. What is the correct reason for the assertion? That helium is very less soluble in blood. Okay, option A is the correct answer. Question number 65 is from the chapter Structure of an Atom, and the question is select the correct statements from the following. So the first statement says that atoms of all the elements are composed of two fundamental particles, which is not true because the atoms of elements are composed of three fundamental particles, not two. Okay, and these fundamental particles are electron, proton and neutron, right? Then the next statement says the mass of the electron is 9.10939 into 10 to the power minus 31 kg. Yes, this is a correct statement. Okay. Third statement says all the isotopes of a given element show same chemical properties. This is also correct. What are isotopes? These are the species of same element which have same atomic number. Okay. They have same atomic number in the periodic table, but they have different atomic masses. Okay, and all these show same chemical properties. Okay, so this is the correct one. And the next statement says protons and electrons are collectively known as nucleons, which is incorrect because protons and neutrons are collectively known as nucleons. Okay, protons and neutrons, not protons and electrons. So this is also incorrect. And then the fifth statement says Dalton's atomic theory regarded the atom as an ultimate particles of matter. This is also a correct statement. Okay, so we have seen that out of five statements, two are incorrect and three are correct. Okay, which ones are correct? Statement B, statement C and statement E. Okay, these three are correct statements. So option C will be the correct answer. B, C and E only. Question number 66 is from the chapter Hydrogen, and the question is which of the following statements are not correct. So we have to find out the incorrect statement. Okay, the first statement says hydrogen is used to reduce heavy metal oxides to metals. Yes, this is a correct statement. What will be the related equation? So let's write down the equation here. Suppose we have Y moles of hydrogen gas. It is made to react with metal oxide MxOY, which is a solid. Then it will reduce it into the metal. Okay, X moles of solid metal plus Y moles of water will be released, which is a liquid. Okay, so this is the related equation. Now let's move to the second statement. It says heavy water is used to study reaction mechanism. Yes, this is again a correct statement. Also, we know that heavy water is used as a moderator in nuclear reactions, right? Moderator in nuclear reactions. Now, what is the third statement? It says hydrogen is used to make saturated fats from oils. Okay. Again, this is the correct statement. Oils are unsaturated and hydrogen is used to make unsaturated oils into the saturated fats. Okay. And this process is known as hydrogenation. Means addition of hydrogen. Okay. So, hydrogenation of unsaturated vegetable oils is done to convert them into saturated fats. Okay. Now let's move to the fourth statement. Statement D. It says the hydrogen-hydrogen single bond, hydrogen-hydrogen bond dissociation enthalpy is lowest as compared to a single bond between two atoms of any element. So this is an incorrect statement. Okay, this is not correct because hydrogen-hydrogen bond dissociation enthalpy is highest as compared to a single bond between two atoms of any elements. Okay, so let's write down here it is highest, not lowest. And this property is used in atomic hydrogen torch. Okay, it is used in atomic hydrogen torch, which generates a temperature of around 4000 Kelvin, and it is ideal for welding of high melting metals. Okay, it is used in the welding of high melting metal. Okay, so this has a very high bond dissociation enthalpy. Now let's move to the fifth and the last statement, which says hydrogen reduces oxides of metals that are more active than iron. No, this is also incorrect because it reduces the oxides of metal which are less active. Okay, less active than iron. And we have already seen the related equation while discussing the first statement. Okay, so here we can see that the first three statements are correct, but the last two statements are incorrect. Okay, so which ones are correct one? A, B and C. A, B and C are correct, and which are incorrect? These are correct, but we have to find out the incorrect one, right? Not correct one. So these are D and E, which are not correct. So D and E, that means option B will be the correct answer. Question number 67 is from the chapter Haloalkanes and Haloarenes, and the question is the given compound is an example of. Options are aryl halide, allylic halide, vinylic halide and benzylic halide. Okay, so here if we look at this compound, we can see that this halide ion is attached to an sp3 hybridized carbon which comes next to a double bond, right? It comes next to a carbon-carbon double bond. So this carbon is known as allylic carbon. Okay, did you get it? Suppose we have two doubly bonded carbons like this. Then the carbon that comes next to one of these doubly bonded carbons, let's say at this position, then this carbon is known as the allylic carbon. Okay, this is allylic carbon. And if the halide ion is attached to this allylic carbon, then this compound will be known as allylic halide. Therefore, option B will be the correct answer, allylic halide. Now let's discuss other options as well. First one is aryl halide. Aryl halide. So this is very simple. In this case, the halide ion is attached to the aromatic ring. Okay. So let's say this is your aromatic ring. Then halide ion will be attached to this ring directly. This is known as aryl halide. Okay. Then the third option is vinylic halide. Vinylic halide. It means that the halide ion will be attached to one of the doubly bonded carbons. Okay. So let's say this is the first carbon, this is the second carbon. These are connected by double bond. Then the halide ion is attached to one of these carbons and this is known as vinylic halide. Okay. Let's take another example of this. Suppose this is a cyclic compound like this and we have a double bond at one of the positions, and if the halide ion is attached to one of the doubly bonded carbons, then this is vinylic halide, right? So here the compound that is mentioned in the question, you can see that the halide ion is not connected directly to the doubly bonded carbons. It is connected to the carbon that comes next to the doubly bonded carbons. Okay, so this is allylic halide. Now the last option is left, right? This is benzylic halide. Benzylic halide. In this case, the halide will be attached to the benzylic carbon. Okay, so this is the benzene ring. This is the benzylic carbon. Okay, this is benzylic carbon. Now, if the halide ion is attached to this benzylic carbon, then this compound will be known as benzylic halide. Okay. Now, I hope you understood the difference among these options. So the correct option according to this will be option number B, allylic halide. Question number 68 is from the chapter Aldehydes, Ketones and Carboxylic Acids, and the question is identify product A in the following reaction. So we can see that in this compound there are two carbonyl groups. Now this compound reacts with zinc amalgam. This is zinc amalgam, as well as with concentrated hydrochloric acid to give a product A that we have to identify. Okay, so this is an example of Clemmensen reduction reaction. Clemmensen reduction reaction. Okay, so what happens in Clemmensen's reduction? In this reaction, the carbonyl groups of aldehydes and ketones are reduced to CH2 group on reaction with zinc amalgam and concentrated hydrochloric acid. Okay, so in this compound, both the carbonyl groups must be reduced to CH2 group. Now let's check one by one. In the first option, we can see that these are reduced to OH group, which is not true. Okay, not correct, because these must be reduced to CH2 group, not OH group. Now in the second option, we have CH2OH here. This is a different kind of structure, so this is also not correct. Then we come to the third option. Here we have again a different structure, so this is not correct. And in the last option we can see that we have a similar structure and the carbonyl group positions, that means these two positions, we can see that there is CH2 group. Okay, nothing mentioned means there are CH2 groups and at these positions. So this will be your correct answer. Option number D will be your correct answer. Okay. Question number 69 is from the chapter Electrochemistry, and the question is the conductivity of centimolar solution of KCl at 25 degrees Celsius is 0.0210 per ohm per centimeter, and the resistance of the cell containing the solution at 25 degrees Celsius is 60 ohm. The value of cell constant is, okay, so what is given here? The conductivity is given as 0.0210 per ohm per centimeter, right? And the resistance R is given as 60 ohm. We have to find out the cell constant, that is G star. Okay. Now we know that the conductivity is equal to the product of conductance and the cell constant, right? Also we know that the conductance is the reciprocal of resistance, okay, that is equal to 1 by R. So conductivity K is equal to conductance, that is 1 by R, into cell constant, that is G star, and we have to find out the value of cell constant G star, so that will be equal to conductivity into resistance. Okay, now let's put the values. 0.0210 per ohm per centimeter is the conductivity and resistance is 60 ohm. Okay, so if we multiply it, we'll get 1.26 and the unit will be per centimeter. Okay, because per ohm and ohm will get cancelled. Okay, so 1.26 per centimeter, that means option B will be the correct answer. Question number 70 is from the P block elements, and the question is amongst the given options, which of the following molecules or ion acts as a Lewis acid? Okay, so what is a Lewis acid? It is the species which has vacant orbitals in its outermost shell, and due to the presence of vacant orbital they are able to accept electron pairs. Okay, so they are the species which accept electron pair due to the presence of vacant orbitals in their outermost shell. Okay. Now options are H2O, BF3, OH- and NH3. So the correct answer will be option number B, that is BF3. Okay. So here we know that boron belongs to group 13 elements and it has 3 electrons in its outermost shell, right? So these are 3 electrons. Now there are 3 fluorine atoms here. So these 3 electrons will be shared with 3 fluorine atoms. Okay. So how many covalent bonds will be formed by boron? 3 covalent bonds. Okay, so now after the bond formation, how many electrons are there around boron? 6 electrons. Okay, so it has incomplete octet. Okay, incomplete octet. So the octet of boron is incomplete, and due to that it will try to complete octet by accepting the electron pairs. Okay, so it will accept electron pair to complete the octet. Okay, therefore it will act as Lewis acid. Act as Lewis acid. Now let's check why other options are not correct. So if we talk about the water molecules, so here we know that oxygen has how many electrons in its outermost shell? 6 electrons. Okay, so 2 electrons, 2 electrons and 2 electrons. Now there are 2 hydrogen atoms, so 2 of the electrons will be shared with 2 hydrogen atoms. Okay, so 2 covalent bonds are formed, but here there are excess of electrons. Okay, you can see that there are 2 lone pair of electrons present here. Okay, so these electrons will be donated. Okay, so they will donate electron pairs. So instead of accepting electron pairs, these are donating electron pairs. That means water will act as a Lewis base. Okay, therefore it is not correct. Now the third one is OH minus. So again we have seen that oxygen has 6 electrons in its outermost shell. Here only 1 hydrogen is there. Then in addition to that, it has one more electron. Okay, one negative charge mean addition of one more electron. So this has also excess of electron. Excess of electron which will be donated. But we know that Lewis acid do not donate electron, they accept electron. Okay, now the last one is NH3. So let's draw the structure of NH3. Ammonia, it belongs to group 15 elements, so 5 electrons in its outermost shell, 2 electrons, 3 4 5. Now there are 3 hydrogen atoms. So 3 of the electrons will be shared with 3 hydrogen atoms. Okay, so one lone pair is still left here on nitrogen atom, which will be donated. Okay, so one lone pair present which will be donated. So in only BF3 is accepting electrons, all the other options that are donating electrons. Okay, therefore option B will be the Lewis acid. Question number 71 is from the chapter Biomolecules, and the question is given below are two statements. According to statement 1, a unit formed by the attachment of a base to 1' position of a sugar is known as nucleoside. Okay, so this is a correct statement. Okay, nucleoside is nothing but the combination of base and a sugar. Okay, the base is attached at the 1' position of sugar. Now let's draw the structure of a nucleoside. So we have a pentose sugar first. This is 1' position. This is 2' position. This is 3'. This is 4'. So at 1' there is a base attached to it. Okay. This side we have hydrogen. Then on the 2' position we have a hydrogen, and this side OH. At the 3' also hydrogen, OH. At the 4' position we have here hydrogen, here CH2, and this is the 5' position, and here we have OH. Okay, now this is your nucleoside, a base attached at 1' position of sugar. Okay, now the second statement says when nucleoside is linked to phosphorus acid at 5' position of sugar moiety, we get nucleotide. Okay, so what is the difference between nucleoside and nucleotide? So in case of nucleotide, we have a phosphoric acid linked at 5' position. Okay, phosphoric acid, not phosphorus acid. Okay, so what is phosphorus acid? Phosphorus acid that is mentioned in the question is H3PO3, and this is incorrect because phosphorus acid is not linked at 5' position. Instead, phosphoric acid is linked. Okay, phosphoric acid. Phosphoric acid. And what is phosphoric acid? Phosphoric acid. In this we have H3 PO4. That means 4 oxygens are there. Okay, so let's see how will a nucleotide look like. So first we have a sugar similar to the one we had made in the nucleoside. Okay, so this is your base. This side we have hydrogen. Here we have hydrogen, OH. Here also we have hydrogen and OH. And here we have CH2, and this side we have oxygen, then phosphorus, this side double bond oxygen, this side oxygen, and this side oxygen. Okay, so 4 oxygens are there. This is your nucleotide. Okay, this is nucleotide. So statement 1 is correct, but statement 2 is incorrect because it's not phosphorus acid, it is phosphoric acid. Okay, so statement 1 is true, but statement 2 is false. Option number B will be the correct answer. Question number 72 is from the chapter Structure of Atom, and the question is the relation between Nm, where Nm is the number of permissible values of magnetic quantum number m for a given value of azimuthal quantum number L is. Okay, so we have to find the relation between Nm and L. Okay, so there is a direct formula for this. The number of permissible values of magnetic quantum number, that is Nm, is equal to 2 times the azimuthal quantum number, that means 2L plus 1. Okay, because azimuthal quantum number is always denoted by the letter L. Okay, so is this expression mentioned in the options? No, it is not mentioned. Okay, it is given L equals to 2Nm plus 1, but that is not true. Nm equals to 2L plus 1. Okay, so let's find out the value of L from here. 2L will be equal to Nm minus 1. So L will be equal to Nm minus 1 upon 2. Now is this expression mentioned in the options? Yes, it is mentioned in the last option. Okay, this is L. So L equals to Nm minus 1 upon 2. This is the correct relation. So option D will be the correct answer. Next question, question number 73 is from the chapter Chemical Bonding and Molecular Structure. And the question is, amongst the following, the total number of species not having 8 electrons around the central atom in its outermost shell is. Okay, so 5 species are mentioned here, and we have to see how many of them are not having 8 electrons around the central atom. So let's check one by one. We have ammonia first, then we have AlCl3. Next one is BCl2, next is CCl4, and the last one is PCl5. Okay, so let's check. The first one, nitrogen, is the central atom and it belongs to group 15. Okay, it belongs to group 15. So how many electrons will be there in the outermost shell of nitrogen? 5 electrons. Okay, 5 electrons, plus there are 3 hydrogens, so 3 electrons of hydrogens will also be shared with nitrogen. So there will be 5 plus 3, that is 8 electrons around nitrogen in ammonia. Okay, now next one is AlCl3. So aluminium is a group 13 element, isn't it? So the number of electrons in the outermost shell of aluminium is 3, plus 3 electrons from 3 chlorine atoms will be shared. So 3 plus 3, 6. 6 electrons around aluminium in AlCl3. Next one is BeCl2. So beryllium is group 2 element. So the number of electrons in the outermost shell of beryllium is 2, plus 2 electrons from each of the chlorine atoms. So total electrons will be 4. Okay. Next one is CCl4. So carbon is a group 14 element. Then the number of electrons in the outermost shell of carbon will be 4, plus 4 electrons from each chlorine atom. So total 8 electrons. And the last one is PCl5. So phosphorus is a group 15 element. Number of electrons in the outermost shell of phosphorus is 5, plus 5 electrons from each chlorine atoms will also be shared. So total 10 electrons will be there around phosphorus. Okay. Now we can see that out of these 5 species, NH3 and CCl4 have 8 electrons around the central atom. Okay, so out of 5, 2 are having 8 electrons and 3 are not having 8 electrons. So how many are not having 8 electrons? 3. Okay, so option D will be the correct answer. Question number 74 is from the chapter States of Matter, and the question is, intermolecular forces are forces of attraction and repulsion between interacting particles that will include A. Dipole-dipole forces, B. Dipole-induced dipole forces, C. Hydrogen bonding, D. Covalent bonding, and E. Dispersion forces. Okay, so what are the intermolecular forces? These are the forces of attraction and repulsion between the interacting particles. So dipole-dipole force is a type of intermolecular force. Dipole-induced dipole forces are also intermolecular forces. Hydrogen bonding is also a type of intermolecular force. Dispersion forces are also type of intermolecular forces, but covalent bonding is not an intermolecular force. Okay, so what is covalent bonding? It is a type of bonding that helps in holding the atoms of a molecule together. Okay, so covalent bonding holds the atoms of a molecule together. That means once two atoms come together, then this covalent bonding keeps them together. Okay, so it does not help in the process of attraction or repulsion. Got it? So A, B, C and E will be intermolecular forces, D will not be. So A, B, C and E are correct. So option B will be the correct answer. Question number 75 is from the S block elements, and the question is given below are two statements. One is labeled as assertion A and the other is labeled as reason R. Okay. Now according to assertion, metallic sodium dissolves in liquid ammonia giving a deep blue solution which is paramagnetic in nature. Okay. Yes, this is a correct statement. Now let's see the reason. Reason says that the deep blue solution is due to the formation of amide. No, this is not correct. Now let's see what is the reason for the deep blue solution. We'll write the reaction here. Okay. So we have metallic sodium plus liquid ammonia. So let's say X plus Y moles of ammonia are there. Then what will be the products? First product will be the cationic part. So Na plus NH3X. Okay. And the next part of the product will be electron and Y moles of ammonia. Okay, so this is the ammoniated electron or the solvated electron. Okay, this is ammoniated electron, and this ammoniated electron is responsible for the blue color of the solution. Okay, why? Because it absorbs energy in the visible region of light and imparts blue color to the solution. Okay, it absorbs energy in the visible region of light, and due to that it imparts blue color to the solution. Blue color. Also it is paramagnetic in nature. So we can say that yes, metallic sodium when dissolved in liquid ammonia will give deep blue solution which will be paramagnetic in nature, but it will be due to the formation of ammoniated electrons, not due to the formation of amide. So assertion is correct but reason is false. Okay, assertion is true but reason is false. So that means option number B will be the correct answer. Question number 76 is from the chapter Classification of Elements and Periodicity in Properties. And the question is, the element expected to form largest ion to achieve the nearest noble gas configuration is. Options are fluorine, nitrogen, sodium and oxygen. Okay. So which noble gas is nearest to all of them? Neon gas. Okay. Neon. It is nearest to all these elements. Now what is the number of electrons in neon? 10 electrons. Okay. Now let's check the number of electrons in each of the given elements. First option is fluorine. So the number of electrons in fluorine atom is 9. Number of electrons in nitrogen is 7. Similarly, the number of electrons in sodium atom is 11 and that in oxygen is 8. Now they have to acquire the noble gas configuration, the configuration of neon gas. That means the number of electrons must be equal to that of neon. Okay, neon has 10 electrons. So what will fluorine do? It will gain 1 electron. Okay, it will gain 1 electron to become 10. Okay, so fluorine atom will become fluoride ion F minus. Similarly, nitrogen will gain 3 electrons to become 10. So it will become N 3 minus, that means addition of 3 electrons. Then sodium has 11, that means it will have to lose 1 electron to become 10 electrons. Okay, so it will be Na plus. Plus sign means loss of 1 electron. And oxygen has to gain 2 electrons, 2 electrons to become 10, so it will become O2 minus. Now all these ions have same number of electrons, right? Same number of electrons, that is 10. That means they are isoelectronic species, isn't it? Isoelectronic means having same number of electrons. Now what happens for isoelectronic species? For isoelectronic species, atomic size or ionic size, ionic size is proportional to charge on the anion. Okay, on anion. That means more the charge on the anion, more will be the size. Okay, so anion, which anion has maximum charge? Nitrogen, 3 minus. Therefore it will have maximum size. So option B will be the correct answer. Question number 77 is from the chapter Chemistry in Everyday Life, and the question is, some tranquilizers are listed below. Which one from the following belongs to barbiturates? Okay, options are meprobamate, Valium, Veronal, and chlordiazepoxide. Okay, so what are tranquilizers? These are tranquilizers are powerful drug that helps people sleep or become calmer. Okay, and what are barbiturates? These are a class of tranquilizers which are actually derivatives of barbituric acid. Okay, barbituric acid. And what is the formula of barbituric acid? It is C4H4N2O3. Okay, now out of all the options, veronal is barbiturate. Okay, it is a derivative of barbituric acid, and all others are other classes of tranquilizers. Okay, so option C will be the correct answer. Question number 78 is from the chapter Electrochemistry, and the question is, given below are two statements. One is labeled as assertion A and the other is labeled as reason R. Assertion says that in equation delta Rg equals to minus NF E cell, value of delta Rg depends on N. Yes, this is a correct statement. Okay, what is delta Rg? It is change in Gibbs energy of the reaction. Okay, and that is equal to minus NF E cell, where E cell means EMF of the cell, right? It is the EMF of the cell, and NF represents the amount of charge passed. Amount of charge passed. F is the Faraday constant. Okay, F is constant. That means delta Rg will depend on N. Okay, so this is correct. Now the reason says that E cell, that means EMF of the cell, is an intensive property and delta Rg is an extensive property. This is also correct, that E cell is intensive and delta Rg is extensive. But this reason does not explain the assertion. Okay, it is not the correct explanation of assertion. So both are individually true, but R is not the correct explanation of E. So option A will be the correct answer. Question number 79 is from the chapter Polymers, and the question is, which amongst the following molecules on polymerization produces neoprene? Okay, so it is chloroprene. Chloroprene, which on polymerization produces neoprene. Okay, what is the IUPAC name of chloroprene? It is 2-chloro 1,3 butadiene. Butadiene. That means there are two double bonds at 1 and 3, first and third position, and at second position there will be a chlorine. Okay, so the correct answer will be the first option. Here you can see that this is carbon number 1, this is 2, this is 3, this is 4. So at second position we have a chlorine attached to it, and at first and third position we have double bonds. Okay, so this is 2-chloro 1,3 butadiene, and which will produce neoprene on polymerization, and neoprene will look like this. CH2, C, here we have chlorine, here double bond CH and then CH2. Okay, this is the polymer, neoprene. Therefore, option A will be the correct answer. Now, question number 80 is from the chapter Aldehydes, Ketones and Carboxylic Acids. Okay, so here we have to complete the given reaction. As we can see that we have carbonyl group in the reactant A, that means this is a ketone, okay, and it is reacting with HCN. So what will happen? First, this HCN will break into H plus and cyanide ion, okay, H plus and Cn minus. Now this cyanide ion will act as the nucleophile. That means what kind of reaction is this? This is an example of nucleophilic addition reaction, right? Nucleophilic addition reaction. Now let's see. First we have this reactant. We have a double bond at this position, double bond O. This is A. Now when it reacts with HCN, so we have seen that HCN will break into H plus and Cn minus. That means the solution will have H plus ion as well as Cn minus ion. Okay. So first in this reactant, this bond will split like this. Then at one position we have oxygen and at other position we don't have anything. So what will happen? H plus ion from the solution will come and get attached at this position. Okay. And Cn will get attached at this position. Now in the next step, another H plus ion from the solution will come and get attached at this position. So what will it form? Because there are many H plus ions in the solution, right? So it will be OH2 and here we have Cn. Now OH2 and H2O are same, that means water molecule. So this is water molecules. Now it reacts with concentrated sulfuric acid. Okay, it is heated with concentrated sulfuric acid in the next step. Okay, so what happens? We know that concentrated sulfuric acid is a strong dehydrating agent. Okay, dehydrating agent, so it will help in dehydration or the removal of water molecule. So this OH2 will get removed from here and it will give rise to a double bond at this position. So let's see what will happen. This is the cyclic structure. Here a double bond will develop due to the removal of OH2 from here and Cn will remain at this point. Okay. Now what will happen with Cn? We know that we still have H plus ion in the solution. Now we also have water molecule in the solution. Okay. So this will react with water molecule and it will take part in hydrolysis. Okay. Cn will take part in hydrolysis. So what will happen after hydrolysis? We'll get the final product. So a double bond at this position and this Cn will get converted into COOH after hydrolysis. So this will be your final product C. That means the final product must have a double bond at this position and it must have a carboxyl group at this position. Okay. So let's check one by one. In the first option we have a carboxyl group but no double bond. So this is not correct. In the second one we have a double bond but no carboxyl group. It is aldehyde. So it is also incorrect. In the third option we have a carboxyl group as well as double bond at this position. So yes, this must be the correct answer. In the fourth option and the last one we have OH, not carboxyl group, and we don't even have a double bond here. So the only possible answer is option number C. Okay. Question number 81 is from the chapter Hydrocarbons and the question is weight of 2 moles of organic compound which is obtained by heating sodium ethanoate with sodium hydroxide in presence of calcium oxide is. Okay. So first we have to consider a reaction where sodium ethanoate is heated with sodium hydroxide in the presence of calcium oxide. So let's write down the reaction. Sodium ethanoate, that means CH3, C double bond O, O, Na. Okay, this is sodium ethanoate. Now it is heated with sodium hydroxide, that is NaOH, in the presence of calcium oxide, CaO. Okay, so what are the products obtained? The first product will be methane gas, methane, and the other product is sodium carbonate, Na2CO3. out of these two products that are obtained here, which one is the organic compound? Methane. Okay, methane is the organic compound that about which the question has been asked. Okay, organic compound. So we have to find the weight of 2 moles of methane. Okay, what is the molar mass of methane? Molar mass of methane is 16 grams per mole. That means weight of 1 mole of methane is 16 grams. So what will be the weight of 2 moles of methane? Weight of 2 moles of methane, double, right? 2 into 16 grams, that is 32 grams. So the correct option will be option number A, 32 grams. Question number 82 is from the chapter amines, and the question is, which of the following reactions will not give primary amine as the product? Okay, so let's check. In the first option we have a nitrile, and it is reacting with lithium aluminium hydride, and then hydrolysis is taking place. Okay, now we know that lithium aluminium hydride is a reducing agent. Also we know that nitrile on reduction with lithium aluminium hydride produce a primary amine. Okay, that you have to remember. So what will be the primary amine that will be obtained here? CH3, CH2, NH2. Okay, so this is a primary amine. Now come to the second one. Here the positions have been exchanged. Okay, nitrogen and carbon positions. So here the product that will be obtained, here also you can see that it is reacting with lithium aluminium hydride. So after reduction we'll get CH3, NH, CH2, because nitrogen is in middle, so it will produce a secondary amine, not primary amine. Okay, then let's come to the third one. Here we have an amide. Okay, carbonyl group is there in between, so this is an amide. It is also being reduced with lithium aluminium hydride. So what will be the product that will be obtained? CH3, CH2, NH2. Again a primary amine. And in the last option again we have an amide, but it is reacting with bromine and potassium hydroxide. So this is basically an example of Hofmann bromamide degradation reaction. Okay, Hofmann bromamide degradation reaction. So what happens in this reaction? Here a primary amine is obtained. This is specifically for the production of primary amine by treating an amide with bromine in aqueous or ethanolic solution of sodium or potassium hydroxide. Okay, so what happens here? Migration of an alkyl or aryl group takes place. So here alkyl group is present, so migration of alkyl group will take place. Okay, alkyl group from the carbonyl carbon to the nitrogen atom. Okay, so you can see that this alkyl group CH3 is linked with CO, okay, this carbonyl carbon, and then after that comes NH2. So this CH3 will get shifted to or migrated to this nitrogen directly. Okay, so what will be the product that will be obtained? It will be CH3 NH2. Okay, and as we can see that the final product will contain one carbon less than that present in the amide, because CO will be removed from here. Okay, so this is also giving a primary amine. Okay, this is also a primary amine. So which one is not giving a primary amine? Only the second one. Okay, so option number B will be the correct answer. Question number 83 is from some basic concepts of chemistry, and the question is, the right option for the mass of carbon dioxide produced by heating 20 grams of 20% pure limestone is. Atomic mass of calcium is 40, and a reaction is given in which calcium carbonate is heated to give calcium oxide and carbon dioxide. Okay, so here we have to heat 20 grams of 20% pure limestone. Limestone is nothing but calcium carbonate. Okay, so what will be the mass of 1 gram of 20% pure limestone? 20% pure limestone, it is 20 by 100. Okay, that is 1 by 5. So the mass of 20 grams of 20% pure limestone will be, because we have to heat 20 grams of 20% pure limestone, so it will be 1 by 5 into 20, that is 4 grams. Okay, so we can say that according to this question we have to heat 4 grams of pure limestone, and then we have to see how much carbon dioxide will be produced. Okay, so for that we have a reaction, calcium carbonate, that is limestone. It is heated at 1200 Kelvin. This reaction is also mentioned in the question. Calcium oxide and carbon dioxide are produced. We have to find out the mass of carbon dioxide produced. Okay, so what is the molar mass of calcium carbonate? It will be 100 grams, and the molar mass of carbon dioxide will be 44 grams. Okay, because 12 for carbon and 32 for 2 oxygen atoms, so 44 grams. Okay, now we can see that 100 gram of calcium carbonate is producing 44 grams of carbon dioxide. So 4 grams of calcium carbonate will produce will produce 44 divided by 100 into 4. Okay, so on solving this we'll get 1.76 grams. Got it? According to this reaction, 100 grams of calcium carbonate produces 44 grams of carbon dioxide, but we have to heat 4 grams of calcium carbonate. So this mass of calcium carbonate will produce 1.76 grams of carbon dioxide. Therefore option A will be the correct answer. Question number 84 is from the chapter Haloalkanes and Haloarenes, and the question is identify the product in the following reaction. Okay, so you can see that the reactant is a disonium salt, right? N2 plus Cl minus is on the benzene ring, that means a disonium salt is there. Now in the first reaction it reacts with cuprous bromide and HBr. Okay, so we know that mixing freshly prepared disonium salt with cuprous chloride or bromide results in the replacement of this disonium group, that is N2 plus Cl minus, by a chlorine or bromine. Okay, so here we are reacting it with cuprous bromide. So we can say that mixing of the given disonium salt with cuprous bromide, that is Cu2Br2, will result in the replacement of disonium group, that is N2 plus Cl minus, by a bromine, right? So this N2 plus Cl minus will be replaced by bromine. So what will be formed? We will have this benzene ring as it is, and then here we'll have a bromine. Okay, so this is the product that we will obtain in the first reaction. Okay, now in the second part, this was the first part. In the second part, this will react with magnesium in dry ether. Okay, so what will be formed? Magnesium will get attached. Okay, magnesium will get attached. So we'll get this one. This is the benzene ring, and here we'll get MgBr. Okay, now in the third part it will react with water. Okay, in the third reaction we have to perform hydrolysis of this. Okay, so this phenyl magnesium bromide, this is phenyl magnesium bromide, on hydrolysis will give us benzene ring. Okay, benzene plus magnesium, then here OHBr will be obtained as a byproduct. Okay, so the main product is benzene, so the first option will be the correct answer. Okay, this is the benzene ring. Question number 85 is from organic chemistry, and the question is the number of sigma bonds, pi bonds and lone pair of electrons in pyridine respectively are. Okay, so here we can see that there are 6 sigma bonds as part of the ring. Okay, 1, 2, 3, 4, 5, 6. These are 6 sigma bonds. Then 7, this is 7, 8, 9, 10 and 11. So these are 11 sigma bonds. Okay, how many sigma bonds? 11. Now let's count the number of pi bonds. So 1, 2, 3. 1, 2, 3. These three are pi bonds. Okay. So the number of pi bonds is 3. And lone pair, there is only one lone pair on nitrogen atom here. Here we have a nitrogen, right? So here we have a lone pair. So lone pair is 1. So the number respectively will be 11, 3 and 1. That means option B will be the correct answer. Now we are starting section B of chemistry. Okay. So question number 86. It is from the chapter thermodynamics. And the question is, which amongst the following options is the correct relation between change in enthalpy and change in internal energy? Okay. So we know that change in enthalpy is represented by delta H and change in internal energy is represented by delta U. So this is a direct question. We know that delta H is equal to delta U, that means change in internal energy, plus delta nRT. Ng means number of moles of gas. Okay. R is the gas constant and T is the temperature. Okay. So according to this, first option should be the correct answer. Option number A. Question number 87 is from the chapter Alcohols, Phenols and Ethers, and the question is, consider the following reaction and identify products A and B. Okay, so we can see that in this reaction we have an ether and it is being heated with hydrogen iodide to give two products A and B, and we have to identify these two products. Okay, so we know that the general formula of ether is R1O R2. So let's draw this reactant again, the structure of this reactant. We have a benzene ring here, then CH2 is attached to it, then oxygen, and then a benzene ring again, right? So we can say that on the left hand side of oxygen there is R1, so this part is R1, and on the right side there is R2, so this benzene ring is R2. Okay. Now when it is heated with hydrogen iodide, first of all it will dissociate into H plus ion and I minus ion, right? Now what will happen to ether? One of the bonds that oxygen is making will break. Okay, we know that oxygen is making two bonds, one with R1 and the other with R2. Okay, so one of them will break. So let's say this bond breaks, the bond between oxygen and R1. Then what will be there? Here we have benzene ring and this side CH2 attached to it. Okay, and on this side of the bond we will have oxygen and benzene ring. Okay, so CH2 will have a plus charge, it will be a carbocation, and oxygen will have a lone pair of electron. Now we already have H plus and iodide ion, right? So H plus will get attached to one of them and it will get attached to the oxygen because oxygen has lone pair of electrons. Okay, so it will get protonated, whereas iodide ion will go to CH2. Okay, CH2 plus, and we know that iodide ion will act as a nucleophile here, right? Therefore, it will attack the carbocation. So what will be formed? The final product will look something like this. Here we'll have CH2I because iodine has come here, and to this side we'll have a phenol, right? OH. So these two are the final products A and B. Now, one question that you may ask, that why didn't we break the bond between oxygen and R2? Okay, so this is because in that case iodide ion would have to come to this part and it will be very difficult reaction because of the delocalized electrons of the benzene ring that will repel iodide ion. Okay, because iodide is a nucleophile, so this will be repelled by the delocalized electrons of the benzene ring, whereas this CH2 plus will not repel iodide ion, right? Therefore it is more suitable that iodide ion comes to this CH2 part and hydrogen ion goes to this part. Okay, so these two will be the final products, and according to that option number B should be the correct answer. Okay, CH2I and here OH, right? In the first option we have CH2OH, which is not correct. Similarly, option number C and D also cannot be correct. Only option number B is correct. Question number 88 is from the chapter D and F block elements, and the question is, which of the following statements are incorrect? So we have to find out the incorrect statement, right? The first statement says all the transition metals except scandium form MO oxides which are ionic. Yes, this is the correct statement. This line is directly taken from the NCERT book. Then the second statement says the highest oxidation number corresponding to group number in transition metal oxides is attained in Sc2O3 to Mn2O7. This is also correct. This line is also from NCERT. Then the third statement says basic character increases from V2O3 to V2O4 to V2O5. This is incorrect because basic character decreases. Okay, basic character decreases, not increases. In fact, acidic character increases from V2O3 to V2O4 to V2O5. So V2O3 is basic, V2O4 is less basic, and V2O5 becomes amphoteric. So you have to remember that V2O5 is an amphoteric oxide. Okay, amphoteric. That means it can react with acid as well as base. Then we come to the fourth statement. It says V2O4 dissolves in acids to give VO4 3 minus salts. This is also incorrect. So when V2O4 dissolves in acids, it gives VO2 plus salts, okay, not VO4 3 minus salts. Then we come to the last statement, which says CrO, chromium oxide, is basic, but Cr2O3 is amphoteric. This is also a correct statement. Okay, so both are oxides of chromium, but one is basic and the other is amphoteric. So here we can see that statements C and D are incorrect. Okay, C and D are incorrect, others are correct. So we have to find out the incorrect one. That means C and D only will be the correct answer. Option number B. Question number 89 is from the chapter Alcohols, Phenols and Ethers, and the question is which amongst the following will be most readily dehydrated under acidic conditions. So let me draw option number 1. It is not given here, so it looks something like this. Here we have an OH group, here also we have OH group, here we have hydrogen, and this side CH3. So now if you see, in all the options we have OH groups, right? In the first option and second option we have two OH groups. So what happens when there is an OH group? Then under acidic conditions, protonation occurs because oxygen has a lone pair of electron. So protonation of oxygen occurs. Then there is formation of carbocation. Okay, OH2 plus is formed because one more hydrogen is added here, and due to plus charge there will be a formation of carbocation, right? Now this OH2 can be written as H2O, right? Two hydrogens and one oxygen. Then later on it is removed. It is removed as water molecule. Okay, so this is known as dehydration. This is the general mechanism. Now we have to see out of all the given options which one will be most readily dehydrated. Actually all will get dehydrated, but which one will get most readily dehydrated? So in order to determine that, we have to compare all these. So we can see that in option number B, C and D there is an NO2 group, but in option number A there is no NO2 group. Now this NO2 group is an electron withdrawing group, isn't it? Withdrawing group. So what does it do? It decreases the stability of carbocation. Stability of carbocation. But in option number A there is no electron withdrawing group. Due to that it will most readily get dehydrated as compared to other options. Okay, so option number A will be the correct answer. Question number 90 is from the chapter General Principles and Processes of Isolation of Elements, and the question is the reaction that does not take place in a blast furnace between 900 Kelvin to 1500 Kelvin temperature range during extraction of iron is. Okay, so out of all the reactions, the last one, Fe2O3 plus CO gives 2FeO plus CO2, will not take place in this temperature range. Okay, therefore this will be your correct answer because this reaction takes place in a low temperature range, 500 to 800 Kelvin, whereas others take place in the high temperature range, that is 900 Kelvin to 1500 Kelvin. Also out of the first three, this third one takes place in the slag formation zone, which also comes under this temperature range. Okay, so the correct option will be option number D. Question number 91 is from the chapter Aldehydes, Ketones and Carboxylic Acids, and the question is identify the major product obtained in the following reaction. Okay, so merely by looking at this reaction we can understand that this is a tolerance test. Tolerance test, and we know that tolerance test is used to distinguish aldehydes and ketones. So you can say that this is your part of tolerance reagent. Tolerance reagent, that is ammoniacal silver nitrate solution. Now this is aldehydic part, isn't it? Whereas the upper part is your ketonic part. This is ketone and this one is aldehydic part. So we know that in tolerance test the aldehyde is oxidized to its corresponding carboxylate ion, that is COO minus. Okay, so there will be change in this part, whereas ketonic part will remain unaffected, right? In addition to that, we know that silver is in +1 state in this tolerance reagent, so it will get reduced. Okay, aldehyde will get oxidized, whereas this silver ion will get reduced to pure silver, thus giving a silver mirror appearance. Okay, so let's see what will be the final products. This we have a benzene ring, here we have a ketonic part which will remain unaffected, and here this aldehydic part will get converted into COO minus. Okay, it will get oxidized to carboxylate ion, plus will get silver mirror, so 2Ag, because Ag plus ion has been reduced to pure silver, plus water will be there and ammonia will also get separated. So the major product is this one. So here if we see the option number A, here we have an OH group here which is not correct. Okay, we should have a carboxylate ion. Now in second option we have a carboxylate ion. Yes, this is correct. Then in third option we have a carboxylate ion, but here the ketonic group has also changed to OH group, which is not correct because there should not be any change in the ketonic group. Okay, and in the last option again we have an OH here, so incorrect. Only option number B is the correct answer. Okay. Question number 92 is from the chapter Solid State, and the question is what fraction of one edge-centered octahedral void lies in one unit cell of FCC? So we know that the total number of octahedral voids in FCC are 4, right? And octahedral voids consist of edge centers and body centers, right? Now what happens? One edge center octahedral void is shared among 4 unit cells. Okay, or we can say that one edge center is common to 4 unit cells. Okay, so we can write it like this: 4 unit cells have one edge center, right? Now it is asked that how many or what fraction of one edge center is there, okay, in one unit cell. Okay, that means contribution of each edge center is asked. So 4 unit cells have one edge center. So one unit cell or each unit cell will have 1/4 edge center. So the contribution of one edge center will be 1/4 in one unit cell. Okay, so 1/4, that is option number B will be the correct answer. Question number 93 is from the chapter Equilibrium, and the question is the equilibrium concentrations of the species in the reaction A plus B gives C plus D are 2, 3, 10 and 6 per mole respectively at 300 Kelvin. Delta G naught for the reaction is, the value of R is given. Okay, so the concentration of A is given as 2 per mole, concentration of B is given as 3 per mole, that of C is 10 and that of D is 6 per mole. Okay, now first of all we know that the equilibrium constant K equilibrium is equal to the product of concentration of products, that is C and D, upon the product of concentration of reactants A and B. Okay, so let's put the values. C is 10, D is 6, A is 2 and B is 3. So on solving this we'll get 10. So this is your equilibrium constant. Now we have to find out the value of delta G naught. So there is a direct formula for this, which is minus RT ln K. K is K equilibrium, right? So it can be written as minus 2.303 RT log K. Now we just have to put the values in this formula. So minus 2.303 into R. So the value of R is given 2 calorie per mole Kelvin. So let's put the value only 2 into T is your temperature. So temperature is 300 Kelvin. It is also given in the question. Then log K. Log and K is 10. So the value of log 10 will be 1. And on solving this, we'll get minus 1381.8 calorie. Okay, so minus 1381, that means option number B will be the correct answer. Question number 94 is from the chapter hydrocarbons, and the question is, consider the following compounds or species. So these compounds are mentioned, and it is asked that the number of compounds or species which obey Huckel's rule is. Okay, so we know that according to the Huckel's rule there must be 4n plus 2 pi electrons in the compound, right? Then we can say that the compound is following the Huckel's rule. We can put different values of n to find the required number of electrons. For example, if we put the value of n as 0, then we'll get 4 into 0 plus 2, that is 2 electrons. If we put the value of n as 1, we'll get 6 electrons. If we put the value 2, we'll get 10 electrons. 3, then 14 electrons, and so on. Okay, so if the compound contains these numbers of electrons, then it is following the Huckel's rule. So let's check one by one. In the first compound, we have how many pi bonds? 1, 2, 3, 4, 5. So 5 pi bonds are there. So how many pi electrons? 10 pi electrons. That means 2 electrons make one bond, right? So 5 bonds means 10 electron. So 10 is there. That means yes, number 1 is following the Huckel's rule. Then we come to the next one, number 2. So 2 pi bonds are there. That means 4 electrons plus 1 lone pair is also there. So 4 electron plus 2 electron, that is 6 electron in total. So 6 is also there. Yes, number 2 is also following the Huckel's rule. In the third one, we have only 2 pi bond, that means 4 electrons. So this is not following the Huckel's rule. Okay. In the fourth one, we have 1 pi bond, that means 2 electrons plus 1 lone pair is there. So 2 plus 2, that is 4. So this is also not following Huckel's rule because 4 is not here. Then in the fifth one, we have 1 pi bond, that is 2 electrons. So yes, this is following the Huckel's rule. Number 5 is following. In number 6, we have 1, 2, 3, 4 pi bonds. Okay, 4 pi bonds, that means 8 electrons. So 8 electrons will not follow Huckel's rule. Then in the last one, we have how many pi bonds? 1, 2, 3, 4, 5, 6, 7. 7 bonds. That means 14 electrons. Okay, we are talking about pi bonds and pi electrons only. So yes, 14 electrons is following the Huckel's rule. So number 7 is also following Huckel's rule. So how many compounds are following Huckel's rule? 4 compounds. So let's see, option number D, 4 will be the correct answer. Question number 95 is from the chapter coordination compound, and the question is, which complex compound is most stable? Okay, so if we compare the compounds given here, then we can see that in option number A, C and D, all the ligands are monodendate ligands, whereas in option number B, a bidendate ligand is given, and we know that a bidendate ligand forms more stable complex. Therefore option B will be the correct answer. Okay. Question number 96 is from the chapter redox reaction, and the question is, on balancing the given redox reaction, the coefficients A, B and C are found to be respectively. Okay, so let's write down the main reactants and products of this reaction. On the left hand side, the reactants are A Cr2O7 2 minus plus B SO3 2 minus, and on the right hand side we have the products 2A Cr3 plus B SO4 2 minus. Okay, so these are main reactants and products. I am not mentioning H plus and H2O here. Okay, so let's solve this first. The oxidation state of each chromium atom is +6. Okay, whereas on the right hand side the oxidation state of each chromium is +3. So we can say that there is a decrease in oxidation state of chromium. Okay, so decrease in oxidation state of chromium is 3. But this is the decrease in the oxidation state of each chromium, and here there are 2 chromium, Cr2. So for 2 chromiums there will be the decrease in oxidation state, that is 2 into 3. Okay, so we can say that the total decrease in oxidation state of chromium will be 2 into 3, that is 6. Okay, now this is important. Now we come to the sulfur. What is the oxidation state of sulfur on the left hand side? It is +4, whereas on the right hand side the oxidation state of sulfur is +6. So in this case there is an increase in oxidation state of sulfur, right? There is an increase in oxidation state of sulfur, and that is equal to 4 plus 2, 6. That means there is an increase of 2. Okay, so we know that for a balanced reaction, the decrease in oxidation state of chromium should be equal to increase in oxidation state of sulfur, right? And the decrease in oxidation state of chromium is 6, whereas the increase in oxidation state of sulfur is only 2. But we have to make them equal. So for that we can multiply the right hand side by 3 so that it becomes equal to 6, right? That means if we multiply the number of sulfur by 3, then we'll get the reaction as a balanced reaction. Okay, so if we put the value of B as 3, okay, then this equation will be balanced. That means if the number of chromium is 1, if the value of A is 1, then the value of B should be 3. Okay, so if the value of A is 1, then the value of B should be 3. In that case the reaction will be balanced. So here in the given option, let's check where the value of A is 1 in the last one and the value of B is 3 in this option only. So it is quite clear that option number D will be the correct answer. But here we haven't determined the value of C yet. Okay, so let's check that. We have to balance the charge as well in order to determine the value of C. Okay, so how can we balance the charge? On the left hand side, what is the total charge? For chromium, it is -2. Okay, so let's balance the charge. Okay, so if we talk about the charge, then on the left hand side we have -2 for chromium and -6 for the sulfur, this one. Okay, because there are 3 sulfurs, B, the value of B is 3, so 3 into -2, that is -6. So the total charge on the left hand side is -2 -6, that is -8. And on the right hand side, what is the total charge? For this one, it is 2 into 3, that is 6. Okay, plus 6. And for this one, it is -6. Okay, because B is equal to 3, so 3 into -2, -6, so +6 -6. So we can see that on the left hand side the charge is -8, whereas on the right hand side it is 0, but we have to make them equal and opposite. Okay, so for a balanced reaction they should be equal and opposite. So what can we do? On the right hand side, if we add +8, then it will become -8 this side and +8 this side. In that case the charges will be balanced. Okay, so we can add 8 plus 8 charge on the right hand side. Okay, so since this is an acidic medium, you can see there is an H plus ion, so this medium is acidic. That means how can we add +8 charge? By adding 8 H plus ions. Okay, so the value of C should be 8 because the number of H plus ion is C, and we know that we have to add 8 H plus ions here, so the value of C will be 8. That means option number D is now confirmed that it is the correct answer. Question number 97 is from the chapter Environmental Chemistry, and here two statements are given. Statement 1 says the nutrient deficient water bodies lead to eutrophication. Statement 2 says eutrophication leads to decrease in the level of oxygen in the water bodies. So in the light of the above statements, we have to choose the correct answer from the options given below. Okay, now we can see that the first statement is incorrect because nutrient rich water bodies lead to eutrophication. Okay, not nutrient deficient, nutrient rich water bodies. How? Because nutrient, let's write it down here, nutrient rich water bodies, they support a dense plant population. Okay, support dense plant population. So this plant population kills the animal life. Okay, so animals are deprived of oxygen because all the oxygen is taken up by the plants. Okay, and hence it results in the subsequent loss of biodiversity. Loss of biodiversity. This is known as eutrophication. Eutrophication. So it's nutrient rich water bodies which lead to eutrophication, not deficient. Then the second statement says eutrophication leads to decrease in the level of oxygen. Yes, this is correct because all the oxygen is taken up by the plants. Okay. So first statement is incorrect, but second one is correct. So first, let's see which one will be the correct one. Third one, right? Statement 1 is incorrect, but statement 2 is true. So option number C is the correct answer. Question number 98 is from the chapter Haloalkanes and Haloarenes, and the question is identify the final product D obtained in the following sequence of reactions. Okay, so we can see that the reaction starts with an aldehyde which reacts with lithium aluminium hydride, and we know that lithium aluminium hydride is a reducing agent, so it will reduce this aldehyde into an alcohol. Okay, aldehydic group will reduce into the alcoholic group. So what will be the product A? The product A will be an alcohol, that is CH3 CH2OH. Okay, so this is your A. Now this A reacts with sulfuric acid. This is heated with sulfuric acid, and we know that sulfuric acid acts as a dehydrating agent. So it will get dehydrated. That means this OH will be removed plus one hydrogen will be removed. Okay, so water molecule will be removed from here. Okay, dehydration will take place. So what will we get? We will get an alkene. So CH2 double bond CH2 will be obtained after dehydration. This is your product B, right? Now this B reacts with HBr to give a product C, isn't it? So we know that HBr will get added to it. Okay, to one of the hydrogens, hydrogen will get attached, and to one of the carbons, hydrogen will get attached, and to another carbon, bromine will get attached. Okay, so what will be the product here? We'll get CH3 CH2Br. Okay, this is your product C. So we have already solved till till C, but we have to determine the main final product, that is D. Okay, so we can see that C is undergoing a Woods fitting reaction. Okay, it is reacting with an aryl halide in the presence of sodium and dry ether. Okay, so this is an example of Woods fitting reaction. Woods fitting reaction. So what happens in Woods fitting reaction? It involves combining of two alkyl or aryl groups to form a new carbon bond, carbon-carbon bond. Okay, so both the groups alkyl and aryl groups will link or will join together. Okay, our product C was CH3 CH2Br, right? This was the product C. Now it is reacting with this aryl halide with sodium in dry ether. So the sodium and bromine will be removed as sodium bromide, and these two groups, this alkyl group and this aryl group, will join together. So what will be the final product? This will look something like this. This is the benzene ring, and here we'll get CH3 CH2. So the final product will look like this. Okay, this is your product D. So here we can see option number D is the correct answer. Okay. Question number 99 is from the chapter Surface Chemistry, and the question is pumice stone is an example of. Options are gel, solid sol, foam and sol. So we know that pumice stone is a solid sol where the dispersed phase is gas, dispersed phase is gas, and the dispersed medium is solid, right? So option number B will be the correct answer. And now we have come to the last question. It is from P block elements, and here we have to match list 1 with list 2. Okay, so in list 1 we have oxo acids of sulfur, and in list 2 we have bonds. Okay, so the first one is peroxo disulfuric acid. So from the name itself it is clear that two sulfuric acids will be there, okay, which are linked together. So let's draw the structure for A. We have S double bond O, then OH here, and one oxygen here, and one more such molecule will be there. So S double bond O, OH and oxygen, and these two oxygens will be linked together. So how many SOH bonds are there? 2 bonds. How many S double bond O is there? There are 4 S double bond O, okay, and 1 SOOS bond, okay. So the correct match for this will be number 3. 2 SOH, 4 S double bond O and 1 SOOS bond, okay. So A will be matched with 3. Now let's come to the second one, B. This is sulfuric acid. So this is the simple structure, S double bond O, and then 2 OH will be there, okay. This is sulfuric acid. So how many SOH bonds are there? 2. And how many S double bond O? This is also 2. So which will be the correct match? Fourth one, 2 SOH and 2 S double bond O. So this is the match for B. So B will be matched with number 4. Now the third one, that is number C. This is pyrosulfuric acid. So let's see the structure of pyrosulfuric acid. This is S double bond O, then OH. See, the difference between number C and number A will be that in number A we have two different oxygens, but in number C there will be only one common oxygen here. Other things will be same, okay. So there is one common oxygen. This will be common to another sulfur also, and then rest of the things will be same, double bond O and then OH here, right. So in this case, how many SOH bonds are there? 1 and 2. How many S double bond O is there? 4, right, and 1 SOS bond, okay. This is 1. So which will be the correct match for this? First one, 2 SOH, 4 S double bond O and 1 SOS. So number C will be matched with number 1, okay. And the last one, number D, is sulfurous acid. So let's see the structure. S double bond O, 2 OH will be there, and one lone pair of electron will be there in sulfurous acid, okay. So how many SOH bond? 2. And how many S double bond O? Only 1, okay. So the correct match for D will be number 2, 2 SOH and 1 S double bond O. That means option A will be the correct answer, isn't it? So here we complete all the chemistry questions from NEET 2023 paper. We'll be back with another session soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice the same questions from our website www.examsnet.com. And for more information, you can download our app from the link given in the description box. Okay, thank you.